All right, stuff we're going to do today, just like when we did simplest radical form. Some of you are going to pick this up right away today with no problem. Somebody's going to take a few days to get there, which is fine because we're going to spend today, we're going to spend Monday, and we're going to spend Wednesday working on this. And then Friday, we're going to take a quiz over it next week. So if you don't quite pick it up today, don't panic. We've got a lot of time yet to figure this stuff out before we get to the quiz. And just as a reminder, next week, actually a week from today, we're going to start using those scientific calculators. So if you have one of those, start bringing that next week. If you don't have one of those, you can check it out from me. You just need the ID to check it out. We'll start using those on Friday. Oops, I put the wrong number here. This is 8-3. And normally I don't label the name of the section, but I'm going to do it today. Section 8.3 is over special right triangles. There are two types of special right triangles. We're going to give you the first one today. And it's the easier of the two to do. And then we'll get the other one Monday. We'll show you the other one. Now, this first part you don't have to write down. I'm just going to show you where this comes from. It's not really important that you know where it comes from. I just want you to see it in case there was any question as to where it came from. I'm going to start with a right triangle. And this one's going to be what we call a 45, 45, 90 triangle. Because it has a 45-degree angle, another 45-degree angle, and a 90-degree angle. We just kind of shortcut that and call it 45, 45, 90. Now, this one's a special right triangle because these two angles are congruent. And if you go back to first semester, if these two angles are congruent, what do I know about the sides across from them? They're also congruent. That's what makes this one a special right triangle. Those two sides, which we call the legs, are going to be congruent together. Now, I'm going to abbreviate leg with an L. And I'm going to abbreviate the hypotenuse here with an H. And then what I'm going to do here is I'm going to formulate a formula that you're going to use anytime you have a 45, 45, 90 triangle. Now, to do this, it all comes from the Pythagorean theorem that we did in section 2. Since you have a right triangle, we can find missing sides by doing a squared plus b squared equals c squared. And we usually start with the c. C is your hypotenuse, which is h. And then the a and the b on this one are going to be the two legs, which are both L. And then if you go back to algebra last year, if you add two terms that have the same exact variables, like L squared plus L squared, you're going to get 2L squared. You add the numbers out front, which are the ones you don't see, and then the L squared plus L squared remains an L squared when you add it. H squared on the right. And we're going to solve for h on this one. So if you remember back to section 2, if you had x squared equals something, you took the square root of both sides to solve for x. We're going to do the same thing here. Get h squared to be just h. We're going to take the square root of it. We're going to do that to both sides. The square root of h squared is h. And the square root of 2L squared, I'm going to rewrite this as the square root of 2 times the square root of L squared. And we can simplify one of those. Square root of L squared, we know is L. So we have the square root of 2 times L equals h. And what we will usually do, if you have a variable or a number behind the square root symbol, we'll usually write that in front of it because you don't want to accidentally leave this little square root hanging over the top of it and make it look like a square root of 2L. So we bring that L in front. That way you can tell it's not under the square root symbol. L times the square root of 2 is H. This is the formula we're going to use on our 45, 45, 90 triangle. L represents leg, square root of 2, and H represents the hypotenuse. On any 45, 45, 90 triangle, the hypotenuse will equal a leg times the square root of 2. So that's going to be our formula. We'll put that up here. This works on any 45, 45, 90 triangle. Just kind of write it out a little bit here more. The hypotenuse is going to equal a leg times the square root of 2. If you can remember this formula, then it's really just a matter of plugging in the numbers and solving the equation. And there's a couple different ways we can show this to you. I'm going to start with the easier of the two. But before I do, any questions on this equation here? Okay, let's show you how it's going to work. Directions are going to tell you to find X. And then they're going to give us a 45, 45, 90 triangle. Sometimes they're going to mark both angles as 45. Sometimes they just mark one angle as 45. But if they do that, we can know the other angle is 45, because if you add up all three angles in the triangle, you get 180. 90 and 45 add up to 135. You take 180 minus 135, you get 45. So even if they just mark one of the angles, you'll know the other one's 45 if it's on a right triangle. Now in this right triangle, we're going to be asked to find X, which is the hypotenuse. And we have a leg that is 6. And same thing's going to happen here. Sometimes they're going to label one of the legs. Sometimes they're going to label both legs. Just depends. In the end, it really doesn't matter. Just need to use one of them. Now, find X on this one. As soon as I see it's a 45, 45, 90 triangle, I know I'm going to use my formula. Hypotenuse equals a leg times the square root of 2. So I'm going to rewrite that down. Hypotenuse equals a leg times the square root of 2. And then you just have to use your picture to line up the parts. The hypotenuse in your picture, if you look at it, your hypotenuse is X. We have our equal sign. We want the leg next. Both of your legs are 6, so it doesn't matter which one you pick. You can put 6 in for the leg, and you got the square root of 2 behind it. We're going to be leaving our answers in simplest radical form this chapter. This is simplest radical form, so that's as far as you have to go right there. X is going to equal 6 times the square root of 2. Really pretty straightforward when they want you to find the hypotenuse. Let's try another one of those. We're going to turn our triangle upside down. Right angle's up in the upper right corner this time. They give us a 45-degree angle, so that tells us we have a 45, 45, 90 degree triangle. They want us to find X, which is the hypotenuse. This time they're just going to give us one leg, which is 7. All right, same exact process here. We know we've got a 45, 45, 90 triangle. When we have that, the hypotenuse will equal a leg times the square root of 2. Then we put in the parts. The hypotenuse on our picture is X. Don't forget your equal sign, that has to come down. The leg on the picture is 7. We have square root of 2 behind it. This is simplest radical form. That's all we have to do on it. All right, that one's pretty straightforward. When they ask you to find the hypotenuse, it's a real quick answer. Okay. Any questions with those two? Okay, sometimes they're not going to ask you to find the hypotenuse. Sometimes they want you to find a leg. And when they do that, it's just a little bit more work. It's not a lot. But it involves a couple more steps. Picture's going to start off the same way. They're going to show us we have a 45, 45, 90 triangle. This time around, we're going to find the legs. So X is going to be one of the legs, or they may mark both of them. And let's put a hypotenuse of 5. Since it's a 45, 45, 90 triangle, the two legs will be the same. They're both X. That's what we're going to solve for. And since it's 45, 45, 90 triangle, we can use our formula. Hypotenuse equals leg times square root of 2. This one's going to start the exact same way, but we'll have to finish it a little bit differently. This time, your hypotenuse is going to be a 5. It's going to equal the leg. Either leg is X. Doesn't matter which one you pick. And we got the square root of 2 behind it. Now I'm going to take it back to algebra last year just real quickly. If we had something like 2x equals 10, and we wanted to solve for x, what did you have to do to both sides? Divide by 2. When you did that, those 2's reduced down to 1, leaves you an x on the left. 10 divided by 2 is 5. That's algebra. Now, this is still algebra here. We're doing the exact same thing. It just looks a little different because you have a square root over there. We want to get the x all by itself. Up here, when you had a 2 in front of it, you divided by 2. Here, you've got a square root of 2 behind it. What would I have to divide by to get the x all by itself?
2.
Not 2.
5. Or x.
No, square root of 2. Is there a difference between 2 and the square root of 2? Yes. If you put 2 in your calculator, you'll get 2. If you put the square root of 2 in your calculator, it's going to be 1 point something. I put 2 square root, I get 1.414. Okay. 2 and the square root of 2 are two completely different things. They have two different values. So on this one, you're going to divide by the square root of 2. What that does is it reduces those down to 1. Because anything divided by itself is 1. That leaves you x on the right. And then if you look at the left-hand side, we have a square root in our denominator. We leave a square root in the denominator. Nope, can't do that. All right, so what we're going to do is what we call rationalize the denominator. This goes back to Monday. When you have that square root of 2 in the denominator, we're going to multiply by a fraction equivalent to 1 that contains the square root of 2. That fraction would be the square root of 2 over the square root of 2. And when you multiply fractions, you multiply straight across. 5 times the square root of 2 would be on top. You do the shortcut on the bottom. What's the square root of 2 times the square root of 2? 2. We got our x on the right. 5 and 2 cannot be divided by the same number, so this is as far as we go. That's our simplest radical form. All right, did we lose anybody in here when we did the rationalizing the denominator? Like we did on Monday. Good with that? Okay. Let's try another one. We again have a 45, 45, 90 triangle. This time x is going to be one of the legs. And let's have our hypotenuse be a 60. Start this one. We notice it's a 45, 45, 90 triangle. So we can use our formula. Hypotenuse equals a leg times the square root of 2. And let's test you guys out a little bit here. What's going to go in for the hypotenuse? 16. 16 is your hypotenuse. Don't forget to bring your equal sign down. We have the leg. Next, what's our leg? X is the leg. And then same thing with square root of 2. Don't forget to bring that down. Okay, now we got x times the square root of 2. We want to get x all by itself. So we'll divide both sides by the square root of 2. When we do that, these square root of 2's reduce down to 1, leaves you just an x on the right-hand side. Left-hand side, you got a square root of 2 in the denominator. We can't leave it like that. So we're going to multiply by the square root of 2 over the square root of 2. And this one we will be able to simplify. When you multiply across the top, it's 16 times the square root of 2. On the bottom, you got your shortcut. Square root of 2 times the square root of 2 is 2. But this time, 16 and 2 can be divided by the same thing. What can they both be divided by? No, 16 and 2. What can they both be divided by? 2. 16 divided by 2 is 8. 2 divided by 2 is 1. So if you want to put this in simplest radical form, it's going to be 8 times the square root of 2 equals x. Now, I've only done 4 at this point. How many think they're kind of getting the hang of it already? Okay, that's a pretty good sign. Let's try a couple more. This time we're going to let you guys make it up. We're going to have a 45, 45, 90 triangle. We're going to make x one of the legs. What do you guys want the square root? What do you guys want the hypotenuse to be? You know, you pick. 46. 46. All right. Start the same way. You see it's a 45, 45, 90 triangles. You can use our formula. Hypotenuse equals leg times the square root of 2. Then you can put the parts in. Your hypotenuse is 46. The leg is x. And you got your square root of 2 behind it. We're trying to solve for x. We want to get the x all by itself. To do that, I'll divide both sides by the square root of 2. That gets rid of those square roots of 2 on the right. So you can do just an x. And then again, you've got a square root of 2 in the denominator. We don't want to leave it down there, so we're going to multiply by the square root of 2 over the square root of 2. Doing that on top gives you 46 times the square root of 2. Doing the shortcut on the bottom, square root of 2 times the square root of 2 is 2. 46 and 2 can both be divided by what? Divide them both by 2, so that's going to be 23. That's going to be 1. Simplest radical form, we get 23 times the square root of 2 equals x. All right, let's do one more. I'm going to throw one last thing at you that could show up when you're doing these. All right, this one, let's have x be the leg. We got to put 45 in here, so 45, 45, 90 triangle. And then for our hypotenuse, we're going to do, let's say that's 10 times the square root. Every once in a while, they're going to throw a square root into one of the sides. And that may make it look like it's going to be more difficult, but it's really not. It's just the exact same thing. So we've got our figure here. We know it's a 45, 45, 90 triangle. We can use our formula. Hypotenuse equals the leg times the square root of 2. And then we can start putting our parts in. Hypotenuse is 10 times the square root of 2. Got your equal sign. The leg on this one is going to be x. And don't forget the square root of 2 behind it. Now it looks a little bit different, but we're going to do it the exact same way. To get x all by itself, what would I divide by? Square root of 2. We do that to both sides. And what's going to happen here is on both sides, the square root of 2's are going to reduce down to 1. That leaves me a 10 on the left, it leaves me an x on the right. X is going to be 10. All right, did we lose anybody on that last step? I think they're getting the hang of it now. Okay, we want to do a few more together, or do we want to try some on our own? Raise your hand if you want to do some more together. Okay, let's give you 2 of these to do. I'm going to give you 1 of each example. One easy one, one hard one. Which one do you want first? The easy one or the hard one? The hard one first. Try both of those. And if you get stuck, just get as far as you can on it. See how far you can go. One more step. These look pretty good for the most part. I need more time to finish this one. All right, we'll start with the more difficult one. The first one, when they give you the height, or when they ask you to find the leg, that's the more difficult of the two. Since it's 45, 45, 90, we'll go hypotenuse equals leg times square root of 2. Hypotenuse is 20. The leg is x, and you have square root of 2 behind it. To get the x all by itself, we'll divide by the square root of 2. So those cancel out, leaves us an x. And then over here, 20 over the square root of 2. We don't want to leave that square root of 2 in the denominator. So we're going to multiply by the square root of 2 over the square root of 2. On top, you get 20 times the square root of 2. Do the shortcut on the bottom to get 2. And then one last step. 20 and 2 can both be divided by 2. 20 divided by 2 is 10. 2 divided by 2 is 1. Simplest radical form, your answer is going to be 10 times the square root of 2. All right, any questions on how I got to here? Okay, second one, 45, 45, 90 triangle. This time they want you to find the hypotenuse. This is the easier of the two versions. I tried to make it a little more complicated by putting a square root on the side there, but it really doesn't make it a whole lot more difficult. Start by putting in the hypotenuse. The hypotenuse is there. Multiply that by a leg. Your leg is the square root of 3. You got to bring the square root of 2 down behind it. Some of you left it like this. These two we can multiply together. If you remember back to yesterday, if we had square root of 4 times square root of 5, we got square root of 20. You multiply the numbers underneath, keep the square root above them. Same thing here. Square root of 3 times the square root of 2, square root of 6. And that can't be reduced. You can't do. There's no perfect squares that are a factor of 6, so that's as far as we can go. That is simplest radical form. Any questions on how I got to the square root of 6? How many of you got both of these right? Okay, hopefully time. All right. How are we feeling now? Does anybody need to see more examples? I think figured out. Okay. Then if you go to the front of your packet, now remember, we're splitting section 3 up into 2 parts. We're doing half of it today and half of it on Monday. So we're going to do half of the assignment today. We'll do the other half on Monday. All right, we've already done the stuff in red. Let's see, the first part, the part that goes with the 45, 45, 90 triangle is this part. Page 562. Numbers 1 to 3 and 8 to 13. And then Monday, we're going to do the other special right triangle. That'll be the second part of the assignment. So when you get done with today's part of the assignment, you don't have to turn it in to me today because we're going to finish it off on Monday. So just hang on to it. We'll do the other half Monday. If you've got these things done, page 552 or the Pythagorean theorem worksheet, you haven't turned those in. We'll turn those in today. That's it. The rest of the time is yours to get things done. Answers are on Google Classroom if you want to check them while you go.